Hey team, welcome back to our next installment of video notes. We are doing Pythagorean theorem today, which seems kind of weird since we've done Pythagorean theorem throughout the year. So like, why are we having a lesson on it now? So it's going to be easy. You're gonna already know what to do, but then there's just like one little new piece that we're going to add to it. It's not hard, but today we're going to do the Pythagorean theorem to help us find missing side lengths of a right triangle, since that's what this whole chapter is about, is finding missing lengths and angles in right triangles. So let's fill out these blanks here. So the Pythagorean theorem, again, let's go down a bit. It's used to find missing sides of a right triangle. A few keywords there. You can only use it to find sides, and it has to be the right triangle. If it's any other triangle, we can't use Pythagorean theorem. The sides A and B are called legs. So right here, this guy's a leg, this guy's a leg. Whereas C is your hypotenuse, which we already knew. And remember how you can tell which one's your hypotenuse? It's the one across from the right angle. Like, think of that right angle as like making an arrow towards your hypotenuse. And again, the Pythagorean theorem is a squared plus b squared equals c squared. So if you just want to see a quick little demonstration why this works, I'll show you here. So I'll let it play, then I'll explain. Wow. So what just happened there is the area of this square, since we're taking a squared, which would be the area of this square, because it's the side times its side, so a squared, plus the area of this squared, which would be this side length b, so b times b has to equal c squared, which is this side here. So those areas dump into the other area. Do you guys see how it fills it up? So those areas are the same when you add them together. Pretty cool stuff here in enriched geometry, let me tell you. All right, let's try a few examples here. Oh, JK, gotta fill out one more thing. So this is what's new. You can use the Pythagorean theorem's converse to classify if your triangle is acute, right, or obtuse. So it's basically the same process, but we just don't know if it's a right triangle or not. So if it's acute, your hypotenuse, your C, the biggest side length, will be less than a squared plus b squared, which makes sense, right? Think of acute's tiny, so I would want my c squared to be tinier than the other two. C squared is equal to a squared plus b squared if it's right. Well, duh, because that's already the Pythagorean theorem. We know that's already true. And then if our c squared is greater than a squared plus b squared, it's obtuse, which again should kind of make sense. Think obtuse is larger, like it's a larger angle. So if my c squared's bigger than my two other sides, it should be obtuse. But this is a good nugget of information right here. Always keep the c squared on this left side. It will help make your life easier, because then you can tell by just looking at the inequality symbol. If it's less than, it's acute. If it's greater than, it's obtuse. And C is always your biggest side. Okay, now let's try a few examples. So it says, first determine if three side lengths could form a triangle. If so, to classify as acute, right, or obtuse. So this is kind of prior information. Remember, we did this, I don't know, maybe it was during distance learning. It was a while back. But you can figure out if three side lengths can form a triangle by taking the two smaller sides, and they have to add to be greater than that third side. So let's just check real quick. My two smaller sides are 3 and 7. So 3 plus 7. Is that greater than 9? 10 is indeed greater than 9, so that checks out. And now from here, we can do our Pythagorean theorem test. So this works, so we can put yes. Okay, so now from here, take your biggest side, which would be 9. So I'm going to have 9 squared. I'm going to leave it blank right here because I don't know what it's going to be. And then 3 squared plus 7 squared. And now we just crunch out these numbers. 9 squared is 81. Again, I'm going to leave it blank. I don't know what's going there yet. 3 squared is 9. 7 squared is 49. Finish it off by adding those two together. 81. Again, I'm leaving it blank. We don't know yet. 9 plus 49 is 58. And now we can compare. How does 81 compare to 58? It is greater than, so this would be obtuse. That's it. That's all we're doing today, kids. It's a great day. It's always a great day, but today's especially a great day. Okay, let's try another one. So again, we first have to decide if the three sides can make a triangle. So you take your two smaller sides, which in this case would be 5 and 11. Is 5 plus 11, is that greater than 16? Well, 5 plus 11 is 16. Is 16 greater than 16? No, it's not. So, nope. A triangle is not possible. So you can put not a triangle, not possible, whatever you want to put. Not a triangle. All right, one more, folks. So again, let's see if we have a triangle that can be formed out of these three side lengths. So you take your two smaller ones. 20 plus 21, is that greater than 29? 20 plus 21 is 41. 41 is indeed greater than 29. So we're in business. Yes, we have a triangle. And now from here, we do our Pythagorean theorem test. Okay, so pick the biggest side, our C. Our biggest side here is 29. So 29 squared, leave it blank, we don't know yet. 20 squared plus 21 squared. And now we crunch these numbers out. 29 times 29 is 841. Leave your little space. 20 times 20 is 400. And 21 times 21 is 441. Add them together. 841. 400 plus 441 is also 841. So how does 841 compare to 841? They are equal. And if we get them to be equal, it is right. All right, we have a right triangle there. Okay, since this lesson's not, I don't think, too difficult and didn't take very long to do, so we're not going to do the last example, okay? I'm going to also have you do a quick Google form on this for like an assignment today as well. And I'm sorry that I'm loading you up. I'm just trying to set up the week so when we come back to face-to-face full-time with everybody next Monday, we can kind of start off on a review day, I think, is my plan. So I'm sorry that I'm making you do double duty. I promise it'll be short, sweet, and to the point, nothing too extravagant. But please do that. Email me with any questions you have. I hope you have a super duper day, and I can't wait to see you in class. Toodaloo. Goodbye.